Hello everyone, I am Chandrima Banerjee, a student of Department of Chemistry, Bolpur College. Today I like to present my dissertation on the topic of chelate under inorganic chemistry. My dissertation is divided in four groups. First, introduction, second, types of chelating ligand, third, factor affecting of stability of chelate complex, and fourth, application. Now the first content is introduction. The term chelate was first introduced by Sir Gilbert T. Morgan and H. J. K. Drew in 1920. Chelation has its origin in the Greek word chile, that means claw of a crab. The crab captured the food with the help of a claw. In similar way, ligand captured the metal ion with the help of the donor atoms. Thus, explain the concept of clinging or hanging with a strong grip. So, as a definition of chelate, we can say that when a polydentate ligand coordinates to a metal ion through more than one donor site atom, a ring-like structure is formed. It is called chelate and the ligand is called chelating ligand, and the whole process of formation of ring is called chelation. Now, next is classification. So, as a definition of chelate, the ligand may be bidentate or polydentate. Bidentate ligand which bound to the central metal atom through two donor atoms. Example, ethylene diamine. Here two nitrogen atoms are donor atoms which bind to the metal ion M and form a chelate complex. Next, oxalate ion. Here two oxygen atoms are donor atoms which are bind to the metal M and form chelate complex. Next, polydentate ligand. Polydentate ligand are those that coordinate with central metal atom by more than two donor atoms, such as tridentate that bind to the central metal atom through three donor atoms. This is the example of tridentate ligand. Next, tetradentate ligand that bind to the central metal atom through four donor atoms. Here, four nitrogen atoms are the donor atoms. Next, pentadentate ligand which bind to the central metal atom through five donor atoms, and this is the example of pentadentate ligand. And next, hexadentate ligand which bind to the central metal atom through six donor atoms. Here, six donor atoms are available, thus it is considered as a hexadentate ligand. Next content is factor affecting stability of chelate. Stability of chelate complex is depending upon the three main factors, which are size of the chelate ring, number of the chelate ring, and chelate effect. So the first factor, which is size of the chelate ring. The stability of the chelate ring is depending on the size of the chelate ring. It is found that the five-member chelate ring, which have almost no strain, are significantly more stable than the complex with six-member chelate ring, which are in turn much more stable than the complex with four and seven-member chelate ring. Next, the number of chelate ring. The chelates in which the polydentate ligand form more number of cyclic or ring structure is more stable than the chelate in which a polydentate ligand form lower number of ring structures. Next, the chelate effect. When bidentate and multidentate ligands form complexes through chelation, the stability constant increases. This is why even for the similar binding sites, the chelating ligands form more stable complexes compared to non-chelating ligands. This phenomenon is known as chelate effect, which is mainly arises from entropic failure. Here two reactions are given. It is found that the second complex is 10 to the power 10 times more stable than the first complex. So as a thermodynamical aspects, we can say that the stability of chelate can be explained on the basis of equilibrium constant, in turn related to del G del H del S, as del G equal to del H minus T del S and del G equal to minus RT ln K. In chelate formation, T del S term contributes significantly to make del G highly negative. In reaction 1, the number of changes in molecule is 0, so the entropy change is also 0. In reaction 2, the number of change in molecules is 3, so the entropy is also increases. In second reaction, the T-tail's term may now even more dominant over the del term, which makes del G highly negative and make the reaction spontaneous. Now I am presenting my last content, which is uses of chelate. So the chelate compounds have various applications in different fields such as medicinal purpose, analytical chemistry, agricultural food field and food industry. Here I am going to discuss these first two fields only. So in medicinal purpose, the method of removal of excess metal in human body with the help of the chelating ligand is known as chelation therapy. As an example, excess copper 2 plus in human body is causes Wilson disease. For removal of excess copper 2 plus, triethyl tetramine is used, which bound to this metal ion and form a stable complex. And this is their complex. Next, excess calcium 2 plus ion in human body can be detoxified by chelating ligand EDTA4 minus and removed from the body easily. This is the calcium EDTA complex. Next, analytical chemistry. Metal ion in the solution can be detected by specific chelating agents. As an example, nickel 2 plus is detected by DMG, which is known as dimethylglyoxime in alkaline medium, which form red rose color chelate compound. And this is the nickel DMG complex, and this is the color of this complex. Next, oxalate is used to precipitate calcium in radiochemical determination of strontium 85 and calcium 45. This is calcium oxalate complex. And here is my references. Acknowledgement. Thank you.